Welcome back. Today, we're going to assemble the full LEGO Technic motorcycle in SolidWorks, taking every part we've modeled so far and bringing them together in a complete working assembly. If you've ever struggled with assemblies or you're not quite sure how all the mate types fit together, this is the perfect project to practice on. This video is recorded in real time, so you'll see the actual workflow, how I position parts, how I choose the right mates, how I troubleshoot alignment issues, and how I keep the feature tree clean as the build gets more complex. I'll show you the exact steps and process I use when I'm building any SolidWorks assembly, from the first mate all the way to the final checks. And if you want to follow along in your own time, you can download the model files for this entire project and build the motorcycle for yourself. It's a great way to practice assemblies, understand Technic geometry, and get comfortable with SolidWorks at your own pace. Welded fully defined. My name's Chris. I'm a certified SolidWorks expert, and I'm here to teach you how SolidWorks can make you a better and more efficient product designer. So this is the SolidWorks model that we're going to be assembling in this demonstration. You can see I've got it neatly organized at the moment. Then in the feature tree, I've got everything here in mostly one folder. I do have a sub-assembly in here. I'll explain why we do that a bit later. So there's one sub-assembly in this project. There is also a link that is part of a chain that is created using a belt feature and a chain pattern, which is something I've never ever done before doing this project. So I've done it once, but I think I've got enough experience now to show you how to repeat the same process. There's a bunch of other things in this project that we'll cover off as well. We'll look at all the basic mates that are used, how to best align parts, troubleshooting, and one of my favorites that I'm really starting to get the hang of now through assemblies and some parts as well, but that is display states. I have to show you how you can get your copy of these parts so you can follow along at your own pace. Now, important note, you will only be able to use the SolidWorks parts directly, being editable parts, if you have SolidWorks 2023 version or newer. If you have SolidWorks 2022 or older, unfortunately, I don't have the SolidWorks files for you, but I do have 3D step files that you can use. There'll be a link in the description to a separate video showing you how you can download and import step files and use them for this project. But to keep things simple here today, I'm going to take those that have 2023 or newer through that process, which is relatively straightforward. So what you need to do to get your copy of the files, first thing you're going to need to do is follow the links to my school community, fully defined. Send me a request, community's free, answer a couple of questions, and I'll get you in as soon as I can. Once you're in the community, you're going to navigate to the classroom. You can see the fully defined SolidWorks by LEGO library. There is a lot of information in here telling you how the library works. I'm going to skip that today. Watch that video in your own time. Click on module 2, click on the link to open that up. And that's going to take you to the view-only version, the Google Sheet, which is the fully defined SolidWorks by LEGO library. Now, here on the homepage, there is more information about how this library can be used. But for this class, we're looking for the motorcycle files. I want you to navigate on the tabs at the bottom to Assembly Library. We can see the motorcycle here at the bottom, and there is a file here, motorcycle-assemblyready.zip. Click on that file. It's going to take you to a Google Drive where you can download a copy of all of these parts in one folder. You're going to download that file. What you want to do is save that file. That's going to save the compressed zip folder. Before you can open the files in SolidWorks, you need to extract them. Once they're downloaded, you're going to right click, click extract all. And once those files are extracted, you're ready to open the assembly file. What you'll see in the extracted zip file is that there's 3 assembly files. There's the assembly ready file. That's the one we'll work with. But the other 2 there are for reference. So the motorcycle assembled is the finished assembly that I showed you on screen earlier. And the front wheel sub-assembly is an assembly file that's within that general assembly. All right. We're going to create the sub-assembly during the process of this demonstration. Everything else in the folder is the parts. You've got every part required for the project. So let's start with the assembly ready file. And assembly ready just means when you open up that file, all the parts are there, at least one of every part. There's no mates in this assembly, and there's no other reference geometry. So all I've done is really just drop every part in so that you've got it all here, and you don't need to go looking for things as you get started. Now, before we start the assembly, there's one other thing that you'll need, and that is the assembly instructions. I've also linked them here in the LEGO library. You can see the motorcycle instructions down the bottom here. Click on that. They'll link you to a PDF file. You can view that in the browser. You can view that in Adobe PDF. You can view that in Adobe Acrobat, PDF Reader. Any type of PDF viewer will be fine. Now, before we actually start mating anything, it's worthwhile taking a minute to think about or plan out your assembly. And the same thing you would do with any product design that you're developing. You want to consider who your audience is, who you're communicating to, what you're putting together the model for in the first place. If it's just play, or just training practice, maybe it doesn't matter so much. But I'm always thinking about professional practice. And in this case, if I'm trying to replicate products such as this, and I look at the image, well, there's a few things that come to mind when I can see the product here and I already know the parts that are going into it. And this is typical of how you might run a product design project anyway. You'll have done your sketches, you'll have worked out what it's going to look like. You start building it in CAD, and then you might build the parts individually or in a master part file, split them out. When you start building the assembly, you're going to have a specific orientation or position relative to the origin where you're going to want to put your parts. In this case, I think some of the first parts we do are down the bottom here in this region, but you can see they're not on the top plane. The top plane is what will be in contact with the wheels. However, we don't have to mate it perfectly in the right position as the very first part. In fact, we don't know the height offset that it's going to have from that top plane. The main thing that we can probably do is just line it up so it's centered. So if we've got the right plane, like going through the middle of the part, and this, whatever part it is that we put in first, as long as that's roughly fixed in place with either, we could use a fixed mate to lock that in place and then build around it. Later, when we get to the wheels or we get to the finish point of the assembly, we can remove that fixed constraint and then add the final mates to get the final position exactly where we want it. The other thing we want to keep in mind when we're building something like this, even though we're following the instructions here, the instructions are made for physical Lego parts in SolidWorks. We can use symmetry tools and pattern tools. We're going to use the mirror component feature that's available in assemblies. We're also going to use the belt feature and the chain pattern feature to do the chain that we can see here. So there's a few tools that we can use in SolidWorks that will just speed things up a bit more than what the actual instructions show us. All right. First thing I'm going to do, so I have put everything in a folder. I'm just going to show the right plane. Let's just make sure planes are visible. Okay. The other thing I want to work out is, where is my front? The last thing I'd want to do is assemble it all facing backwards. This can be important for drawings or rendering or exploded views or animations that you do later. Just helps spend that little bit extra time, get the alignment right as you're starting off. I'm going to show the front plane as well. I'm just going to go to my front view. And so I can see this is the front view. This is the isometric view. All right. So whatever is my first part, which is this, it's a part with 7 holes and it is red. I think it is this one here. I'm just going to make sure I'm orientating it so it's facing towards the front. And so the mid plane of this is going through the right plane. Now, first up, I'm just going to move component tool, just a free drag. I'm going to rotate this around just to get it roughly in line, and then I'm going to mate it. Now, sometimes that makes it a little bit easier to get your mates done straight away, because if something is already perpendicular to a plane, SolidWorks might suggest other mates like a perpendicular or parallel mate rather than the one you actually want, which in this case is going to be coincidence, depending on how the part is built. I'm going to use a lot of shortcuts throughout this video as well. The one I just used there is a hotkey. I have the I key on my keyboard set to isolate. So anything I have selected, When I press I, it's going to isolate that. In this case, it's isolating a part. I can see this is the part that I want. And I can see it's actually the top plane that goes through the middle of that part. I'm going to hold Control, select the right plane, and I'm going to select coincident on the little shortcut bar here that pops up. So it's going to line up those two. I'm then going to, as we talked about earlier, we hide the front plane. I'm going to show the top plane for a second. There's the top plane. All right. We know that there's going to be a gap here. If we can just, like, let's use this right plane and let's use this front plane and make those two. And then for the height, we can either put a fixed constraint on this part, so we could right click it and go fix, or we can say, let's put that front plane and the top plane, let's just put a rough dimension in there. Let's say it's going to be 20 millimeters. All right. Now we'll see this part is fully defined. All right. Everything else is still underdefined. Okay, when we're isolating and we're looking at this part, we get the fully defined information down here. If I isolate, I expect it's very strange. Actually, it's not. It's telling me fully defined, but I know for a fact that there's a lot of things that can move around. So there we go. Now it's saying underdefined. That's here. Everything else, we're going to start to move around it. So I'm going to start a new folder. What I'm going to do is drag this one out of this folder. To do that, I'm going to click drag. I drag it up here, hold the Alt key, and it's going to move it to underneath this folder, which means it actually takes it out. And I'm going to put this in a new folder called Assembled Parts. And I'm just doing this so that we can very quickly hide and show parts that are either have been assembled or have not been assembled. Just make things easier for managing later. For instance, I can grab everything in the loose parts options here. So I'm going to grab everything in this folder, click move component, and I'm just going to drag them off to the side so that they're clear of my assembled area. Press the tick. And the other thing I'm going to do, now that we've started assembling this file, I'm going to do a save as. Of course, you can save it with the file that you've just done. I'm going to change the name of this one to work in progress, WIP. We know that this one then is our active file. We've still got the assembled version there for reference if we need it. All right, first space done. I'm going to hide the front plane. I will keep the right plane there because we will use that a bit more later as we start doing mirrored components. Okay, next part is a long blue one. Now, I don't know the official names of these parts, but we might learn them as we go. So, some quick mates or some quick points on these. It is difficult to see, but if you zoom in on this detail, you can see it's got a little lip on this side, right? And what that is in reference to is this feature here. All right, so this feature is going to be on this side of the part. So there's a couple of ways you can do your mates. The first one, I was using some shortcuts. Another way is to select, let's say, two holes like this, or two circular areas, and then click mate. Again, it's going to bring up the shortcut bar. It's selected concentric for us. We're going to press OK on that. We're not going to lock rotation because we're going to be very specific, very particular about our rotation of our parts. And we're going to make them so that they're all lined up very neatly. We want it to look good in the drawings or renders we do later. I'm going to press OK on that one. Now, to move a part when you're mating it, the trick is to click and hold your mouse button down when you're moving. You don't want to, if you click and let go of your mouse button, it's going to select. But if I click and drag, then I can move or rotate the part around. And sometimes it's easy to do that to make it so that you can see these views to then add the next mate. So we did those two. That's got the position done now. We need to stop the rotation for this one. We're just going to select a flat face and another flat face. SolidWorks is going to make it parallel. And then you can see on the cursor, there is a button, a mouse cursor with a check mark on the right mouse button, which means if I right mouse button press, it's going to accept that mate. Now I can keep this mate window open. It is by default, it is pinned to keep visible, and just keep adding mates. All right, so if I can find the next part, which is this gray L shape, is it this one here? Three holes and then one across. I'll just bring that one down, bring it over here, and I'm going to click on this face and this face, right click OK. accept the mate. Now, if I rotate this down, let's select this face and then the inside face here, press OK. That's adding coincident mate. You can see over on the left, the mates that have been added one by one. Now, if we need to, for any reason, go back and change those, let's say this one, I can right click and delete, or I can click here and I can change the type of mate that it is. So if I wanted to change it to a distance mate, for instance, this is one that happens regularly, I can just put in the number here and it's going to add the distance mate instead of the coincident mate. We'll change that back to a coincident, press the tick, and then press these two surfaces to line them up. Now, you may notice as you're going through this, oh, look, that's a very tight fit. It looks like they've been perfectly measured to fit together. That is half true. When I created all the parts as part of the earlier series, you can find the live stream playlist at the link below. I did so fairly accurately by measuring the parts one by one. Some parts have been created in previous series, but it's always when it comes to the assembly where you can find the interferences or parts not quite right. And in this case, the not quite right is 0.1 or 0.2 of a millimeter. It's very small. So there have been changes as I went through the first assembly version, the one I've already shown you. I did find a lot of those parts where they weren't fitting properly, and I have fixed a lot of those errors. It should make the process for you mating these parts and creating this assembly a lot easier, but it is not perfect and it is not 100% guaranteed that no interferences are there and that everything is going to fit perfect together. If you come upon errors, which we may very well do in this video, you need to work through troubleshooting them. And if you need to change the dimensions of the parts to get them to fit, please be my guest. Let's continue. Now, we're starting slow with these mates, but as we go through some of the basic ones, and you've seen all the basic types, then we're going to jump into a bit of time lapse. So bear with me until we get to that point. Next little trick here, we're doing another one of those blue parts. We've already got one right here. We want to duplicate it. I'm not sure if I can do this with the mate tool open, but to duplicate, I'm going to press Control on the keyboard, then click and drag. No, that does not work. So I'm going to close the mate tool. Now press Control, click and drag. And you can see it makes a duplicate of the part. Another way I could do that is to select the part here in the feature tree, press Control C and Control V. If I do that, it's going to drop a part exactly on top of the one that's already there. That one can be a bit more difficult to click and drag. That's why I often don't use Control C, Control V. If I'm duplicating, I'll normally Control, click, and drag to the side. All right, so let's grab this one, and I'm going to select these faces, concentric mate, select this face here. Now I lost my mate tool. Select these two faces and coincident, and it's just, you can see with that shortcut, it's just been added automatically. If I want to keep the mate tool open, I need to actually select the mate tool, and then it'll stay pinned and I can keep going one after the other. All right, step 1 and 2 done. Let's keep going. Step 3, 2 long red pieces. Let's see if we've got them. There's one and there is the other. I'll bring these across over here. Now it's showing us how they're assembled. So this one's on this side. This one's on this side. It looks like this and this are lined up. Now you can see in the preview here, it has lined those two up but at the wrong orientation. To flip an orientation, I'm going to click this arrow, flip, make alignment. That's going to rotate around. So that's good. I want to come onto this side, click this one, drag it out. Just want to get, it should actually be on this side. Yep. So it's this face and this face that are going to be coincident. And then here, if I want to line up this one, get it all lined up neatly, I'm going to select those two faces to make those parallel. And then I'll bring this part over. I'm going to make this and this concentric. Flip alignment, press the tick, drag it back. I can see that in the picture, the slot is on the side. So I'm just going to rotate it around so it's like this. And then we're going to grab this face and I'm going to guess this face. And if I want to see inside it to get this part like lined up properly, I can select one of the faces here. This part's going to go transparent. And that's happening because in the feature, in the mate property features, the very bottom, there's this button. Checkbox, make first selection transparent. Having that ticked means that when you select a face or a part or a body or an edge, it's going to make that one transparent. It makes it easier to select the next one, for instance, this face, to get that mate added that we need. This is a parallel mate. It's just lining up those two faces to make sure that they're aligned. Okay, another step done. Now, at this point, you can see that we're starting to put a few of the parts from our loose parts folder are over here. And we have this one as well. So we're just going to drop them into assembled parts. And what we can do is I can just click on this folder and I can click on this part. I can see where the part is. It's here. I'm just going to drag it to the assembled parts folder. Or another way you could do that is you can grab everything here. So drag a box over it, right click, hide, and then anything that in the loose parts folder that is showing, for instance, these three parts, I know that those are these three here. I can click and drag and put them in the assembled parts folder at the bottom. Then I can show this one again so that I know that I'm keep picking my parts from this area over here. All right, we have another long 7 part. So I'm going to duplicate that red one. And now actually, before I skip ahead, I've got the model in front of me. And if I have a look on the bottom, I can see that it's actually the gray one that's in the middle, not the red one to the side. So, some of my first guess putting that red one in the middle was actually wrong. So we're going to have to roll that back, change that. It's okay. We're here to make changes and learn as we go. Also, then I don't need to add a duplicate of the second red one. This is where I can start to use my mirror components feature. Right, so let me show you how we're going to make the change. First up, I'm going to delete this. Next up, this part here. I click on this Technic beam, and when I do so, I can see up the top, see this little breadcrumbs here? These are all the mates, or the first 8 mates that have been added to this part. And you can see here is the very first one we did, which was the right plane. That is one that I can now select and press delete on the keyboard. That's going to mean that I can drag this to the side. And now I can click this gray part. I can see what plane is going through the middle of that one. It's going to be the top plane. Hold control on the right plane, add a mate. And now that is the center of my model, not the red one as it was originally. And then to mirror or start our mirror feature happening, I'm going to go to Assembly tab, Linear Component Pattern. Under that drop down, I'm going to select Mirror Components. I'm going to select Mirror Plane. That's going to be our right plane. Components to mirror. The only one I can see that is mirrored so far is this red part. I don't need to go through all the subsequent options. We're not changing any orientation. We're just making a copy on the other side. I'm going to press OK, and that's going to mirror that part for us. And we can see that here in the mirror component feature. And if we press the drop down on that, we can see we have one part there. Now, I'm not sure if you saw it earlier when I showed the preview of the finished assembly, but in the way that I did that, there is only one mirror component feature in the whole assembly, excluding the sub-assembly of the front wheels. And the process that I use throughout this Lego build is that every time I would come across an instruction step that made a mirrored component, I would just add that part to the existing mirror component feature. There are some parts or some types of geometry that do not like to be mirrored, and they want to change their orientation or not make a right or left-hand version of themselves like we would expect. There are some more advanced options to go through in that mirror component feature that we will look at if that comes up, but otherwise, it's a very simple way of just doubling up your assembly if the whole thing is symmetric, and saving you a lot of time. So we'll use that regularly as we go through, particularly through the time lapse as well. Make sure to save regularly, Control S, and let's get on to the next step, which is adding these little black parts in. I've got one of them over here. I'm going to bring that down. We're going to use a few of these. So I'm actually going to leave the original one here, make a copy, and I'm going to use the copy to mate. So let me grab this one, get these two faces, going to mate those, drag it out, select these faces for coincident. And remember, if I want to keep the mate tool open, I need to click the mate tool. Let's click these two to make this part aligned. Now I have just noticed something here. I'm not sure if it's going to be an issue or not. I'm going to hit M for measure. That's another hotkey. From this face to this face, you can see the dimension is 8 millimeters. From this face to this face, we can see it's 7.9. So somewhere along the way, these parts have been created separately. One I've measured differently than the other. One of them might have some interference in the model later. It's not a big deal for us in this project, but that's one of the things that you can check in assemblies as you're going through. Part of the validation process you go through as you're creating your product. Now, as we just did previously, we're going to add this part to our mirror feature. So I'm going to edit feature on the mirror component. I'm going to select the new part. I'm going to press right mouse button for OK. Now we can see it's been mirrored across. Very quick process. All right, let's fly through this next step very quickly, because I want to get up to our first key. I want to get up to our first key lesson of this assembly, which is going to be using the cam mates. That is coming up in a couple of steps. So this one here, I'm going to do concentric. Now I want to keep adding mates because I want to get on a bit of a roll. Let's see if we can't do that. Put that one there. Again, edit the mirror. And here we have what looks like a new sub-assembly. Actually, it kind of is. We can see in this image here, we're making this sort of group of components that we're then going to make to the existing geometry, the existing parts that we've already put together. It's not necessary to make this as its own sub-assembly file. You could do it if you want to practice sub-assemblies. I'm not going to do that today, but feel free, of course, to diverge from my instructions and use the LEGO instructions that are there. What I'm doing is simply a demonstration of some of the tools that you can use. All right, so I'm going to grab that axle, which is 7 long. That one's over here, I believe. Axle 7. Yep. Bring that over and grab one of these parts, I think. A Technic bush. Bring that over as well. Now, you've got to remember that the drawings for LEGO are done for building the physical parts. Doesn't mean we need to assemble in this exact same orientation. So even though that one's going straight up, I can actually leave it going crossways, and I'll do that. But what I will do is just temporarily right click on this one and go fix. So this part won't move and I can make the other parts to it. Now, one thing you could do here is actually bring all the parts together that you need, bring them over so they're right in the right space that you're working with, and then open the mate tool and just go bang, 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 and just do one after the other without having to go and grab each part each time. This is a more complicated assembly with a lot of parts, but if I was doing my own project, okay, and it was only like 7 or 8 parts, I would just have them all together in one, so it's very quick to get everything done that I need. So if I just go through the next couple of pages, I can see that there's a few other parts here that I'm going to use. So I'm just going to bring them over. So I get all of them. This one, another cam, another little nut, and then the gear, which looks to be the small one here. And then this 4-piece fin part. All right, so that's the next couple of steps. So I've got them all close by. Now I can go through and add those mates very quickly. So let's go mate. We might very quickly here, we'll jump into time lapse. All right, so we've reached a point now with our mates and our parts that we're trying to fit a fixed part. So the center point from this hole to this hole should match with what we've done in the assembly. However, our assembly, we've just put our parts coincident all the way up, touching up to one another. We haven't left any gaps. All right. And what is most likely happened here. And what this mate error or warning is referring to is saying, well, your parts are this far apart, you know, all the ones you've mated, but the one that you're trying to mate on the top is this far apart. Which one's right? And that's something you'll find regularly, and I saw regularly as I was doing this assembly the first time around. I have fixed a lot of those things, but there are still many assembly examples that you'll come across doing your own project here where it will be an issue and you'll have to change how some parts are being mated. What we're going to do is press cancel. That's going to delete that mate we tried to add, and press OK. I'm just going to rotate this one around and we can just see roughly how far apart it is. Now, we know that our whole center to center in Lego is basically 8 millimeters. So if there's 4 holes, there's 32 millimeters. If I measure this one to this one center to center, you can see it's 31.65. So somewhere in those mates, all these mates that have happened below it, you know, there needs to be a little bit of extra gap. And we can see there's a bit of extra gap here that really hasn't been taken into account yet. So how are we going to fix it? There's a few ways. First, I'm going to look at this part here. I'm going to see its mate here, the coincident one, and I'm going to delete it. What that's going to let this part do is slide up and down. Now, I still need to add some mates back to it, but I'm not going to let that one control the distance. Instead, what I'll do is grab a mate tool, grab this outer circle, semicircle, and then this face, and now that concentric mate can occur. I press the tick, I press OK. Now that part's fully mated. This one can't move, like it can rotate around, but its position is set. If I want to get the rest of them perfect, what I could do is have a look at what this distance is. I can see it is 0.35. And I could go through the rest of these and offset each of them 0.05 of a millimeter. Maybe it's down here, maybe it's somewhere along the lines. Maybe it's just this mate. Maybe this one and this one here, press isolate, these two should be perfectly centered, shouldn't they? So maybe that's the mate we should add to work out the rightful position. All right, work out the correct position. For now, let's just leave it. It's 0.3 of a millimeter. It's tiny, but if you wanted to later, you could go back and edit those other mates so that they're all perfectly evenly spaced. We're going to move on. Feel free to do that if you feel like it. So now back to our main assembly, our setup. Let's just get back to the key orientation, which is isometric, all right, here. So this is the view, and now we're ready to assemble this part. Now I've had to come back to this one and find the one that was originally fixed, and it was this one going through the middle. So I'm going to right click and press float, and then I'm going to bring this to the side, and it's the red part that's going to fit into these holes here. So I'm going to grab the mate tool. I'm going to grab, these are rounded edges on the axles, grab a rounded face here and mate and flip alignment. Yep, that's okay. And then I'm going to do the same on this one over here. So again, we're doing a similar thing with our mates. We might find that it doesn't fit, but I think because we've already done that spacing here to get it perfectly right, and I probably already troubleshooted the rest to get them perfectly right, that one worked. Okay, let's add another mate here, bring that component up, and I think all those components there are now fully defined, apart from this part that we can rotate. Cool. This is some really good progress. I'm just going to clean up my folders, grab all these parts, move them into the assembled parts folder. Anything else? Loose parts? Well, my trick was, remember, hide everything, see what's left in the folder that's visible, click and drag those. You can see there's quite a few parts now, and I'm going to move them all to my assembled parts folder. Cool. So, and let's keep going. So here we're going to learn about cam mates. First up though, we have to get these heads, cams. Sorry, I'm not an automotive guy. Going to get these parts into the assembly. I do know that they do not fit perfectly, but it should be enough for us. You'll see what I mean in a second. So I'm going to grab this down here, and we need to do 3 of these, but we're not going to do a linear pattern because, as you can kind of see from the preview image, they're actually going to be moving heights at different points relative to the parts that are beneath them. And that is a fun little thing to have a go at. All right, so we've got one there. I'm going to bring that one over here, do a concentric mate, and we're going to get these to line up. Okay, and I'm just going to leave it here, and I'm going to do the other ones. Again, make sure you're saving regularly. I'm just going to hold Control, click and drag, and then open my mate tool and repeat those very similar mates we just did. All right, so we've got those three lined up, and we can see there's a little bit of clearance between them. Perfect. Now, how this part functions in the real model right here is that when these parts are rotated with the gears, with the chain, these will ride up and down. They'll pump up and down following this outer face. And in SolidWorks, that is called a cam mate. It's not one I've done a lot of before, but it's a fairly simple mate to do. The one thing that I will speed you up on here is that instead of selecting this face, I think we get a better result if we use a sketch element that's right in the middle of that part or that feature, that geometry. So I'm just going to go to this part, and I'm going to click on this sketch here, and I'm going to go show sketch. And you can see what that does in SolidWorks. I can see the sketch that's creating that feature all the way back or through here into my assembly. Now, if you have pressed show sketch and you still can't see anything, just check your hide all types icon. If you are hiding all types, that will hide planes, sketches, other reference geometry, even if it is showing in the part. Sometimes you need to uncheck that or make sure that sketches here are visible so that you can see the sketch in your assembly. All right, so I can see that. All right, so I can see that sketch. And what's important there is I'm going to use this little point, the center point of that circle. I'm going to open my mate tool. I'm going to click on mechanical mates. I'm going to click on cam, and I need to select a cam path and a cam follower. The cam path is this face. You can see when I select the face, SolidWorks knows tangency along that direction, and it can work out where that cam path is going to be. So I selected the blue, it's added in these other green faces. Tick. Cam follower is going to be this sketch point here, and that's it. I'm going to press right mouse button OK, and I'm going to go through and do the other ones at the same time. So cam, select this face, select this point, and then the last one over here, cam, oops, sorry, I've got to select the mate type first, and point, and OK, and OK. Now, this is not perfect. You can actually see a bit of an error here, a bit of interference. All right, in fact, on both of those. But I'm just going to rotate this around, and we'll have a look at what's going on. All right, so we're just going to change something here. I'm going to use these two and isolate. The problem we could see is that by using that center point as the cam follower, often the parts are intersecting, interfering. It's not a true representation of what's happening. So what I'm going to do is select this part and select that cam mate and delete it. I'm going to add a new cam mate, but this time select the face rather than the point that's right in the middle. Now what that means is it's going to be the tangency of the face, the entire face, not just a point. But you can see it's already moved to a position of clearance. When I rotate this part now, it's going to move up in a much more realistic fashion to the outside. Yeah, there's still a bit of jumping, as you can see here, but it is much closer without the interference when you're comparing that to what we saw before. So I'm going to do the same to this one in the middle as well. Now, you don't actually have to delete the mate. You can just change the cam follower from a point to an outside edge sketch. That is another option, or the face. Let me try that one. The point on the outside edge. I think I'm still going to get the same issue. Yeah. So I'm getting this interference. So I'll change that again back to the face. Okay. Might get a warning. I'm getting an error now, but we'll see if we can remove that. Doesn't like this one. I will delete it. I'm going to try again. Now, this time it hasn't given me an error, even though I've done exactly the same selections. Exit isolate. We can see a preview now of how that looks. Now, it's not perfect, but it's probably an improvement. Now, the thing that I would like to see and which is difficult in this assembly, is there should actually be I want to do a combination mate. I want to do a distance mate or a range distance mate. What that means is an advanced mate where I have a range of distance. So I could set, it's going to be between 0 and 5 millimeters, for instance, because what I don't want to happen is these parts, the heads here, dipping below. You see here, because it's following this tendency at the bottom, it's coming all the way down. Whereas in the real part, what's happening is this part then just floats and stays on top. So this one would never come lower than this. This part would continue to rotate, and then this part would come back up again. You don't get them dipping down in interference like you can see in this example. All right? But that doesn't exist yet in SolidWorks, so we cannot add it at this point. Save that, and let's continue. The next series of mates are things that we've already come across. A lot of coincident, concentric, some parallel mates to get things lined up. Again, let's time lapse through those, and I'll come back to you when we've got something important to look at. Quick little pause here just to explain that some of the parts you'll see, like in this instance, I'm looking for 2 grey parts, but I have a yellow version in the assembly. How all the parts are done in the LEGO Build and Learn series is any part that has the same geometry but a different color, there's only one part file. To get the different color, it's a configuration. So to change a configuration in the assembly, I'm going to click on a part, and then if it has configurations, you'll see this little drop down. You can see I've got yellow, gray, and default. I click on gray and press the tick, and it's going to change over to the gray configuration of that part. The same thing can happen down here. I can see these 2 earlier. I think this assembly has both dark gray and light gray versions of those parts. I'm going to grab this one here and change it to gray, and grab the one that I did not do a mirror for this, so I'm going to have to grab this one as well, and I'm just going to change the color of both of those early on. Right now, just keep going. And now I can continue from here. All right, the mate I'm about to use here is called a width mate. What the width mate does is let me set the position of this part to match the width with another part. Basically, get it in the center, but you're doing it without selecting 2 center planes. You're doing it by selecting 4 faces on the outside, or 2 faces and a plane. In this example, I'm going to select 2 faces of 2 different parts, and it's going to align them so that the width on the outside is equal. This is under advanced mates, and you can see a width mate here. Our width selection, I'm going to select this face and this face, so 2 outside faces. And then for the inside, I'm going to select this face and this face. You can see SolidWorks just then move the parts to make sure it's equal. We're going to right click, we'll press OK. And now just to verify that for you, let's select my M key for measure. From here to here is 7.8 millimeters, and from here to here is 7.8 millimeters. The one at the bottom is now also aligned because I mated these two faces together. And that is a width mate. All right, so we're at the point here of this little small assembly steps where it's asking us to flip it upside down. So I'm just going to go to this series of parts here, just find the one that was fixed. I think it was this one right here. So I'm going to float that one. Now the whole thing can move. Now we just have to be a bit careful with that. Sometimes I can, rotate some things inside out that aren't fully defined yet. I'm going to grab the move component tool, the rotate component, and just click and drag and try to reposition it based on roughly what we can see in the drawing, just getting it somewhat close. And the next step is to line up, I believe it's these holes here. So I'm going to grab that one, and I'm going to grab, looks like it goes through this. So that's a concentric mate. This one then comes into the center. So this part, I'm going to find this one. I'm going to get the plane that's going right through the middle of that, which is the top plane. And I'm going to mate that with the right plane of our assembly. Okay. Just moves it across ever so slightly. I'm going to rotate the whole thing up. I'm going to grab this part here and put that through the hole as it shows and get it all lined up with these faces on the inside. Now that one should also be right in the middle. We can see something just jumped there. I guess this part's kind of flipped around. This one, Technic Axle 3, if the right front plane there is in the middle, which it is, I can also grab that one and the right plane and make that coincident to get that axle right in the middle. Press the tick, and just before we go too much further, let's just clean up my assembly again. So I'm going to hide all those parts. We can see we're starting to get through them now. Grab all of these, bring them into the assembly parts folder, and grab these ones. Make sure I'm saving regularly as well. So I want to get those. So I'm holding control, and that enables me to select multiple files at once, multiple parts. Drag those down, show those, and show those. So this one here is not in the assembled parts folder. Back there. Okay, looking pretty good. I had two of these. Don't know if I need it. Nope, delete that one. And we don't yet have the other parts to join this all together. So I just leave it at this state. Keep going with the assembly. All right, now here's a point where if, again, some of your dimensions are off in the parts that you're creating and you try and do these mates, you might find issues. So we're about to mirror some component. I'm just going to mirror, I think, this one to the other side. And then we're going to flip. Actually, we're going to move this one downwards. And this one is going to move across a bit over this direction to a position where I believe this and this can meet. All right. So what we're going to do is trying to get this hole and this hole concentric. Voila. And then we're going to grab this one. I'm just going to delete this mate, which made it coincident on the interface there, because this one's going to get pushed through like so, so that it's level with the other three. So I can grab this and make them coincident. All right. The body of the motorcycle starting to come together. There is still some movement, which is here. In reality, this part can move up and down the seat of the motorcycle. You can see this one at the rear. When it drops down, it sits on this small round element here. So this one and this one, we can actually make tangent, right? And that will fully define its location. Now, you may have noticed here, we can see something's going on with the thickness of the parts, and that's partly to do with how these were mated. They're all mated coincident. There's no gaps between them. So we need to introduce a gap so that this one has some room to move. Most of these parts are 7.8 millimeters, meaning if this is, let's say, coincident with this one here, we should actually have like a 0.1 millimeter gap. That's just going to spread things out ever so slightly. All right. We can see this one then should also actually be in the middle of the assembly. So the top plane and the right plane should be aligned, but they are 0.1 millimeter apart at the moment. So again, there's another mate here that we need to move. And I'm just going to have a look at this one. Probably not that edge, maybe this edge here, coincident. I'm going to say that one is also going to need a distance 0.1 millimeter just to spread things out. Okay, now this one at the back is looking good. This one in the middle, still not so much. I think the reason for that is that this part is actually measured 7.85. Should have some clearance. But I think the way it's fitting onto this blue one, if we have a look at, make these transparent for a second, we can see the depth of those features. I think it's probably not quite right on one of those mates. So either this part is too wide or the depth into this part is too shallow. By that, I mean this feature here between this face and this face. I've got it at 0.8. I actually believe it might be 0.9. So I'm just going to edit this one, come right into the feature. I can find the depth here, make that 0.9, accept change, exit isolate. If we have another look now, assembly and at those parts, we can see now this one has a tiny bit of clearance on each side. It's not perfect, all right, but that's good enough to continue on with. Let's continue. About halfway through the assembly now, or a little bit over even. A small trick here to get rotating parts to align. So in this case, like the wheel and the tire, I want them to both rotate at the same time. Just find a plane that's common between them. In this case, the front plane. No, sorry. Top plane from the wheel and front plane from the tire. And mate those two. And you just want to get them coincident or parallel. Either one's fine. Then when that wheel rotates, like you rotate the outside of the wheel, the inside part rotates as well. We're up to the chaining the instructions. I'm going to leave that to last. Complicated, and I just want to get everything else sorted before we go through that one. All right, so we'll come back to it. All right, we are nearing the end. The next steps you can see are all about the front handlebars and the front wheel. Now we're going to build those as a separate sub-assembly within this main assembly. The reason for that, we're not going to use like the mirror component feature because the whole wheels will rotate. Okay, so let's say the spokes that come down, the handlebars either side, if they're mirrored, like they're mirrored when they're flat, but as soon as you want to rotate those and turn them, if you mirror them on the right plane, they're going to distort and break. It's not going to work. So we have to put that as its own sub-assembly. In the sub-assembly, we can mirror it. That's going to save us some time. But in this main assembly here, we can't do that. So the process to do this will be a little bit different. We're going to try and do it in this main assembly here, convert to a sub-assembly, then mirror the components. Let's go through that process. First, we'll get all the parts together for that sub-assembly. We can see we've got, actually, I've just identified an error. I've put the wrong wheels in the back. Let me fix that up real quick. So I've gathered the components for this wheel assembly, the sub-assembly. It's all these ones here. I'm going to select them. I'm going to right click and I'm going to press the drop down. I'm going to click on Form New Sub-Assembly. Apologies, you can't quite see that with my head in the way. Let me try that again. So I'm going to select all those parts. I'm going to right click on one of them in the feature tree. I'm going to click the drop down arrow and then I'm going to click on Form New Sub-Assembly. Now this creates what's called an in-context sub-assembly. This sub-assembly is currently only exists inside this assembly file. You can see it here. It's got that little upper arrow next to the name. I'm going to save this, and what I'm going to do is open the assembly. Right, I can see all the parts here, but now I'm in just a fresh assembly file. I'm going to go File, Save As, and I'm going to give it a name. Now we already have one in our folder that we've extracted. I'm just going to save over the top of that one. I don't need it as reference anymore. Now this gives it a proper name. It gives it its own file that you can open separately to the main assembly. And if I Control Tab back to the main assembly, you can see it's been renamed here. All right. Now we're going to create the sub-assembly mates in its own file, not in this one. In this one, what we'll do at the end is we'll have the finished handlebars wheel, and we'll just do the connection where these connect or plug into the main handlebars, which is along this feature here. All right, but that's going to come in after we've done all the other parts, all the other steps. So let's Control Tab back to this, and now we'll roll back to the very first feature for this, parts for this, which is the handlebar section. Now remember, we're going to try and do this so that we only have to create one side. All right, it might take a little bit extra effort to get it right, but it will be worth it should we get there, because it's going to save us quite a bit of time only having to model or only having to do mates for one side of this sub-assembly. So first, I'm just going to roughly rotate this one into position so that we get like a good starting point. We'll go like this. And I'm just going to fix this one and we'll come back, float it, do the other mates to it a bit later. Now we've got all the components here, so I'm just going to open the mate tool and I'm going to try and do as many mates as I can without closing the tool. So I've already stuffed up with one of the mates, which is this. I am going to float it. I'm going to put this one. Let's see, where is the right plane for this part? The right plane of this part is right in the middle. So I'm going to grab that, grab the right plane of the assembly and make them coincident. And now I'm going to start my mirror feature. I'm going to mirror this component to the other side. Now I can see that there's something wrong with my mates here. This tangent one, I need to remove that. Instead, I just need to separate these two. And I think there's a reason why I don't want to make this just yet. I'm going to leave it floating and keep going with the next features. Now, when you are adding mates and building something up like this, it can sometimes be easier to, like before I add the next step, grab the rollback bar, just jump above the mirror component so that I'm all building on one side of that feature. I can always roll back down and add components to it later on without issue. What can happen is if you leave it down, sometimes you might add your new parts in, but they're mated to the ones that are mirrored. That can cause some trouble sometimes. Just depends on exactly what you're doing. But doing it this way, doing it all on one side, makes things a little bit simpler. That one rotates, that's fine. That. Okay, going to accept those mates, roll down a mirror feature, edit that mirror feature, add in these next components, press OK, keep going. These two parts here are a little bit tricky to mate, given that this is a completely round part. So what we would normally do is look to mate with some of the planes of the part, depending where they are. So I can find a front plane here, and I can see this one. Let me just isolate these two. This one, I can see a front plane. And so both front planes go through the middle of the part. I can use those to mate, and that's going to then line them up. Similarly, the right plane is also through the center. So with those two mates, that part's now fully defined. I have got to fix this first mate though. Bring that up, make it on this face here. Exit isolate, that down, float. I'm getting into a bit of trouble now because a few things can move still, but I think we're getting close to resolving that. So I'm still not going to change anything just yet. We'll keep going with adding features to my mirror component. Parts, adding parts to my mirror component. Now here it lines it up. I'm not going to do that yet. Okay, I can see that it's where it's assembling. I'm going to leave that. It's this next part that I'm going to put in, okay, is going to work out that spacing for me. So I'm going to grab that one and that one. So they're lined up. That's done the space. You can see this now has a neat little gap. This one, I can't quite move it on yet. If I just fix this one temporarily, I can just bring this up. I can float this and then leave it where it is. Okay, that's all moving as one. That's fine for now. I'm going to keep going with the next steps. Just a few mates there to line those up. That was actually the wrong step. That's okay. I'll keep going. We bring this one on. So it's this element here that's going to be mated there. And then I need to rotate this around. Now, again, things are moving at the moment. Makes it a little bit tricky to do some of these mates. If I just right click on one part and fix it, that can just make it easier to do some rotations, get things in the right orientation, ready for mating. Okay, I'm doing a little bit backwards, but I think it'll still be okay. Grab another one of these, those. Okay, so this one looks like this. On this side, it has this disc over here. Move that over. It sits on that face. Yep, and that one can rotate freely. Then inside that is the wheel, and that looks like it is the other direction. Is that one going to be up against this face? Yes. Now, does this one push through? Yes, it does. Okay, I can see one of my mistakes here. So this one is not mated to that face. This needs to pull back, as does this one here. Not everything will be mirrored on this, just some components. Does that fit entirely inside that? It does. Looks like it does. Yep. So that one sits on that face. That looks a lot better now. Okay, I think we'll get the tire on. That was a pretty easy mate, that one. We'll get those two parts aligned. That was top and front, top and top. Okay, and now for the last step, I believe, just going to update the mirror components just to add in the other parts we need. So we're going to want one of these, one of these, one of these, one of these. Right click OK. We can see something is not properly aligned, and that is because our wheels are currently twisted. This one can rotate at the moment when it shouldn't be able to. We're going to fix that, and that is because these two parts aren't mated properly. So I grab this face and this face. They're now fully defined. This one we can float. And if we look at the picture, finished picture, I think we're pretty good now. So what's missing is the red part that fits in between these two. Now we can define that, or we can, allow space for it. I think that's the easiest way to do it. So if we're coming to this part, we can measure this one and see that this is 7.8 millimeters. So here in the sub-assembly, I can do a distance mate and make that 7.8 millimeters. That's going to fully define like that distance between them. And then you can see the whole assembly is really almost as one. So what else do we need to do to fully define this one? Well, we really just need to lock in a position. It's not too crucial. We do want to redo maybe the alignment to get it so it's facing the same way. So at the moment, we did it as per the instructions, but let's try and flip that around. So if I try and rotate this component, you see I can get it to here. It's kind of backwards. If we go to that very original part, which is here, and we flip this mate, it's going to swap it around so that now when we're on the isometric view, like we are right now, it's facing the same way as it will be in our main assembly. Let's do a couple more things. We're going to grab, just want to get it go straight up for one. So I'm going to grab this face and the front plane. Actually, I'm going to grab that whole part. The front plane's going through the middle of it. I'm going to grab the front plane of the assembly and make those two. What we're trying to do here is get this sub-assembly fully defined. And then we're going to use the wheel. So the wheel is the biggest part, the tire on the outside. Going to grab that and the top plane. So you should bring that right up. Top plane, face on the tire, mate. I'm going to make that tangent. And now we can see nearly fully defined. There's a few parts that aren't. We have this one here. We're going to tilt that downwards. We're going to give that an angle. So I'm going to do a quick angle mate and make that 30. And what else to fully define? We've got the tire. The tire can rotate. That's okay. If we want to have it perfect though, let's get it so it's like on this angle. So I'm going to grab, let's see the front plane there, top plane, and make them parallel. And then we can see in our feature tree, all the way down to here, there's a bush that can rotate. If I isolate these two parts, I can see that this and this are not aligned properly. So I'll just quickly align those. And then the last one is this tile. This one, let me grab the right plane, front plane of the assembly and mate those. And now we have a fully defined sub-assembly. As you can see down here, fully defined. No minus signs in the feature tree. That one is all good. So I save that, Control Tab, going to come back into the main assembly. I can see my sub-assemblies here. Just going to drop it out of that folder and just going to move it out so we can see in some space. All we need to do is add some mates to join those two together. So grab our mate tool, going to grab this face and this face, get them concentric, and I do the same on the other side. Now this will work if we have the spacing correct. We've had those issues earlier, remember, where the spacing is not quite right. We can see we've got a similar issue here. So it doesn't want to do the concentric mate. Now we have an option when this kind of thing comes up. We can break other mates to satisfy it, or we can over-define the assembly. Let's over-define the assembly. It's going to highlight the errors for us. And those are errors that we can see in the mates folder here. It's really just the last one we've added, that these two cannot work at the same time. The reason is, and we should know this, the distance between those two is 24 millimeters. The distance between these two is 23.8. And that's all to do with the mate that we put in here, where this one is coincident on that face. But what it needs is a 0.1 millimeter offset distance mate. Now, let me just see if that went through. So I isolate that. No, it did not work. Let me try that again. I'm just going to quickly delete the concentric mate giving us the error. Come back to, going to hide the sub-assembly. So sometimes I find it, you hide and show parts while you're working on your errors. Okay, so what's going on here? The distance mate doesn't want to calculate for some reason. Let's delete also this concentric mate. Still does not want to calculate. Maybe I selected the wrong faces. Just going to delete that one. Okay, so I can see this one can move. And I can see that this one's not a mirror in the assembly, which again is correct because we want it to be able to rotate. So I do wonder if these two needed to be in the sub-assembly as well. It's okay for now. I'm going to continue as is. What needs to happen is that both this side and the other side need that distance mate that is 0.1. You'll see I've got no issues adding it this time. On this side, I'm going to edit this mate, put that one in, 0.1. You see it moves out, no problem. The distance between these two holes is now 24 millimeters. So if I show my sub-assembly, I'm going to add those mates back in. So here and here, concentric, and here concentric. Still doesn't want to do it. It's quite odd, but we'll work through it. Why don't we try it in a different way? We're going to mate these ones. No, didn't want to isolate it properly. I'm going to select these to isolate, because the other thing we're going to do is coincident mate to get the spacing right. So I'll just get that one in place. So let's just try and rotate these two and see how close they are. We should be able to get them concentric, but we're still having issues doing that. All right. This is all part of the troubleshooting. Now let's have a look at what's going on. Have a look at the top view. I just, again, isolate those parts. I think it's the fact that the way they rotate is not quite right. Like right now, it appears that the mates are working. Center to center is 24. Center to center is 24, but it's still not calculating fully. All right, so another approach that we can take here is I can remove these parts from the main assembly, put them into the sub-assembly. That is something that you can do simply by dragging. It's quite odd, but if we think about what side's been mirrored in this assembly or in the original, so in the sub-assembly, we can see all these are the mirrored components, or everything on that side. So let's not take this one. I'm just going to delete it, and I'm going to take this one here, and then I drag it up the feature tree. I'm going to drag it straight into the sub-assembly. Now it says assembly structure editing. It's going to move it, and there's a feature or a mate that's going to be affected. That's okay. Now if I open this sub-assembly, I can see this is back in, and now I can add some mates to it. So I can add the mates that I was having trouble with before. I can line it up. We did have that distance mate. We can delete that now because what we can do is add a coincident mate directly to this. Okay. That part is now fully defined. I can also then update my mirror feature to include that part. Come back into our main assembly, and now we can try a different way of mating. So before we had a distance mate and we had a coincident mate, if we can now add a concentric mate here, now I believe we've solved the issues. We have a rotating sub-assembly on the front, okay, and very clean mates and build to get to this point. Obviously a bit of messing around as we're putting it together, but that's what the assemblies can be like. So that's our sub-assembly, and that is one of our very last steps. Now, just to get it fully defined for the time being, I'm going to grab the right plane of that sub-assembly, the right plane of the main assembly. I'm going to put a little angle mate in, 160, just to put those handlebars on a bit of an angle for us, give us a neat little view. Okay, now that's fully defined. So that's actually the last step. So this part here, we didn't need. Are there any other parts here in the loose parts that we haven't used? I think they've all been moved across. So I'm going to drop them all down to the assembled parts folder. Same with this and this, which means the only loose part we have left is the Technic link as part of the chain. And that is going to be the last feature that we add to this assembly, but it is quite a challenging one. All right, so let's have a look at this chain feature. Now, I'll just show you the detail that we can see here in the instructions. So there is 29 of these pieces, and the way they orientate is that they hook over each other from the top. So if we have a look here, we can see it, each one snaps down onto the one in front of it, and it creates a chain around these two gears. So with that being said, I'm going to close the instructions because we're done with those now, and we're going to focus on putting this detail together. So disclaimer on this element, I'm not an expert on chains and belt mates in SolidWorks, far from it. But as you can see from the example I showed earlier, can be done. And I'm going to try and take you through it in as smooth a way as possible. So first up, we need to create a assembly feature, a belt and chain. Right, now we need to select the cylindrical face or axis of the pulleys, gears, wheels around which the belt will pass. Now, while we're creating a belt, the belt is going to help give us a path for the chain to follow. And the path is not just these two gears, but it also includes this little black element at the bottom. So it's going around the gears and then up over this little bush. And to do that, we need to select the members that are part of that, belt members. We have one gear here, but you can select any of the round faces that are part of that gear or the axis. We have one gear at the back, and then we have this bush in the middle. The chain that you can see, the purple preview, my colors are set to purple, will show you where that chain is going. Clicking the arrow will flip the direction. Now this one in the middle that's going over this bush comes up on the inside. Now we can set a belt location plane. Now for that, I can use one of the parts. So I'm going to try and find one of those gears if I can. See, okay, gear here. And I'm going to use the front plane of that gear for my plane. Now I'm not going to create a belt part. I'm going to engage the belt. I have that ticked at least in the one I did successfully. The other options here, if you already know your belt length, you can set a dimension here and make it driving, and it's just going to, I guess, work out how big it needs to be around each of those. I'm not going to have that. What I do need or have determined from the testing is that the size of these diameters around each of the belt members, the diameters of the pulley, the combination of those and where it's going, and the combination of the features of your train component, how far between, let's say, point A and point B, there's a direct correlation there to get it to work perfectly. So far, I've been unable to do that, partially because I don't want to spend days and days trying to work it out. I just want to get close enough to show you how to do it. And then if you want to become an expert at belts and chains, you can do so. So we have some numbers, some cheating numbers that I'm going to input here. So the first one, the diameter is going to be 16.2. And you can see in the preview that it's going to make this diameter larger on the front gear. On the second gear, it's going to be 24.52. Again, bigger. And then the last one, I'm coming to 12.5. Now this will make more sense once we go to the next step with the chain components. I'm going to press OK. Now that's giving me an error. One of the pulleys is already fixed. Very good. I'm going to unfix whichever pulley that is. Might be this one. Well, there's two mates there. Belt mate. Just going to suppress that feature and that mate. Work out what's going on, why it says it's fixed. They can both turn. They can turn this one. This one can turn as well, but not that it has to. Or maybe that's an issue to do with where I said it was driving. Now, I'm going to grab this mates folder here. You can see all of these different mates. I'm just going to clean things up. A few mates that we no longer have need for, and a lot of mates that are very standard. You can put mates in a folder just like you can put components in a folder and features and sketches in a part. All right, let's try and unsuppress that belt feature. Okay, so I'm not getting an error now, which is good. And you can see with that belt feature in place, when I turn one, it's turning the other. This is really neat. One of the neater parts, I think, of this mate in SolidWorks, or this assembly feature in SolidWorks. Now, so that's part one. That is creating the chain, belt and chain feature. The next part is to get this component in the right place. And let's see if I can remember how I did it last time. We're going to do a chain component pattern. So linear component pattern, we go to chain components. There are different parts, different ways you can have the pitch. We're going to use the third option, which is connected linkage. Our chain path, we're going to select as this sketch, or in fact, let me just use the drop down here as this sketch. So sketch 4 is our chain path. Our chain group is going to be this part. And what we're going to do is select the path link. So the first path link is this element. The second is this opening. And it's obviously very important how accurate the part is that you've measured and recreated for this to work. I think from the other demonstrations that I've found online, a couple of the YouTube channels, tens of thousands of views showing how a chain works, they've been able to do this step accurately, but no one's been able to make them and get them to move using just move components correctly. Often the movement is happening in a movement study. A little bit different, not a big deal. But the way to actually calculate the chain length, the belt length, is to do with, the number of links you have and the space between them. There is some maths there that you can work out to get it done. If I get time in future, I might put something together on that, but that's not the focus of this demonstration today. The path alignment plane, we're going to use the same plane that we used from the gear. So I just want to find that gear again. It's here, and it was the front plane. It's not going to let us use it. Nope, not going to let us use it. So we use the right plane, path alignment plane. Right. We might have to come back to that. We're going to go fill path. So we're not going to fill path. We're going to press 29, and I might need to come back and work out where that plane should be for this to work. Selections for the pattern are incomplete. Does not well let me select that front plane. So the path alignment link, which I was getting wrong, is actually from the chain part itself. So I'm just going to bring that back across, and we'll repeat that process. So I'm going to go chain component pattern. We're going to select a connected linkage. The chain path, we're going to select as the sketch from the belt. So it's sketch 4. We're going to fill the path with 29 instances. Our chain group is this part. and we're going to use this face and this face as our connectors. And our alignment plane is the right plane of the linkage. And then we can see our preview, looking back, looking all right. Let's press the tick, and there you can see our chain now does look like it is upside down. I wonder if there's a way to flip that. I think we can by flipping this. Press OK. Now it appears to be going backwards compared to the instructions. I don't think that makes a difference. Let's see how it moves. That is our chain. And so what it's doing, it's following the sketch path you can see, and you can see the 2 points. So focus on these 2 points here, like the center point of these. It's following the path all the way around. And so those dimensions that we input, it's very sensitive. Now, there is one thing that I can point out in this. If you look at this join here, it is not perfect all the way around. Okay, and that's where I said I've been unable to perfect this feature to get this to perfectly match. I think there is an issue somewhere with the dimensions, the inputs, but as much as I've tried, spent a little bit of time on it, I haven't been able to get that one join to be perfect. Okay, but other than that, you can see that we've made, quite a nice feature there. Now, if we did need to reverse the direction, I believe what we'd have to do would be grab this one here and potentially could flip it around. Don't know if we could even do that now. No, probably somewhere in the chain pattern. Perhaps we need to reorientate it before we do the mate, but I'm not going to waste too much of your time trying to get that exactly perfect today. The one thing I did mention, though, while we can get this mated and we can get this mated, getting them both connected, I don't think it's possible with a complicated chain like this in SolidWorks. I'm yet to find tutorial or demonstration online that shows how to do that. I have found some that claim to do it, but if you watch them, particularly slow them down, you'll see that they work for a little bit and then they stop working. And what they've done, those people that have done, or those tutors that have done those demonstrations, is they've done a gear mate, mechanical mate gear. They've selected a part like this, and let's say a tooth like this. Pressed OK, all right, and then they'll be able to get them both to move. But as soon as this component moves away from the gear, you'll see as it snaps around here, the rotation changes significantly, as you can see on this point. Okay, it's barely even moving. So it's not an accurate representation of what happens in, with a physical part. So I don't have the answer for this. If you do have the answer, please drop it in the comments. Let me know. All right, so that is our finished assembly. Well done. You made it. Now, we didn't get to look at display states, but that is the one last thing I would like to show you before we wrap this up. Display states. Let's just check I've got all the assembled parts showing. Yes. So display states are under the configuration manager, just at the bottom here. I'm just going to bring that all the way up so you can see. This is the default display state. When I was developing the first version of this assembly, putting everything together, to make it a little easier to see the internals, to visualize, I created a second display state. Display states just let you very quickly move between having things transparent, hidden, or different types of views without needing to go and manually click on a bunch of individual parts. You can name display states. So this might be chain mech, all right? You can delete them, you can duplicate them. They're very handy. So in this chain mech display state, what I'm going to do is hide this and grab everything that's here and hide that too. I don't need it. I'm going to grab these, hide those. I'm interested in seeing these internal components here. I'm not interested in seeing all of this. So I'm going to grab a lot of those and hide this, right? And for my chain mech as well, I want to see, for instance, which link, this one. I want to make this one a special color so that it stands out in the assembly. I know which one's the very first one if I need to make some changes. Okay, so I'm just going to make that purple. Right. So this can be the display state called chain mech. Right. So if I wanted to show, let's say, a colleague or a client or manager coming by and I wanted to show them my work very quickly, I don't want to fumble around and have to hide 10 different parts, 20 different parts before being able to show and display this type of model. Right. If I have that display state and I want to keep going back with my work, I just double click on the original and it's going to bring everything back the way it was. I can keep going with my work, I can do other views, etc. You get that time, I want to show that display, show those details, go to display states, double click on chain mech, and it's going to hide those components for me and also change the color of the parts. So display states can be used for colors, transparency, line types. So one thing you could do is click on a part here. I can click on, in this display state, the component display. I might want this part to be hidden lines removed, okay? I might want a lot of parts to be hidden lines removed. I can do that here, right? And have different parts with different view types, for different display states, for different purposes, all right? Communication, drawings, okay? Displays, animations, whatever it might be. A lot of options you can work through with display states. I think I'll do another video on that another day with a bit more detail. Gonna wrap it up here. Thank you so much if you've followed along for each of the videos in this assembly series. I'm really hoping to learn from all the viewers and the ones downloading these files how they found the experience. Was it easy? Was it worthwhile? Did you learn from it? Did you have fun with it? Okay, any feedback you want to give me, I really appreciate that. As well, I really appreciate those that are joining the Fully Defined community on School. It's only fresh. The idea is just to have a place for designers and engineers to share some of their problems, share some tips, tricks, and projects such as these. It's not going to be a high maintenance community. There's not a lot of things you have to do, but it's a good place for me to share a lot of these projects, a lot of ideas, and a lot of courses that I'm trying to put together, including the free ones you can already see now for each of these LEGO projects. The other ones that I've got on the wall there, the off-road buggy and the Volvo wheel loader. There will be more to come. It is a format that I really enjoy, and I think a lot of other people enjoy building LEGO too. So yeah, really just love to hear from you. And why don't you let me know which LEGO set you think I should be attempting next. All right, see you in the next one. Hey, thanks for watching the video all the way to the end. If you enjoyed it, please like and share. If you've got any suggestions for other content, leave it in the comments below. If you haven't already, please subscribe. And there's some other videos here. Check out. Thanks.